Yeah. So here we were presented when it comes to formal definition. I'll just write here formal definition. We are presented with this, like this. On formal definition, right, we are presented with a definition that says, so I'm just gonna define and write this. I'm just going to say definition. The definition says that if we're given any epsilon greater than 0, we must find what? We must find delta, which is what? Greater than 0, such that we'll have that the absolute value of x minus c is greater than 0, which is less than delta. Then we have the absolute value of f of x minus L, which is less than A. Right, we are working this on this. Let's say we're given a limit. The limit says x approaches C of f of x is equal to L. Will always give us a limit like that. So since we're given such a definition, now let's look at the question that we're given now. We're presented with a question. The first question says we should use the formal definition of a limit to show that the limit as x approaches minus 1, so it should approach minus 1, of x plus 6, which will be equal to 5. So first what I said is that you need to first input this minus 1 to check whether the solution is going to be 5, right? So we're going to do that. Then here it means that if we plug minus 1, they will find that this is indeed 5. So we must prove it, that this thing exists, you see, right? So the aim for formal definition is to prove that something exists. So or a limit exists. Then we're going to say given, every time we should write this definition, any epsilon greater than 0, we must find, we should find what? Delta greater than 0, such that, let me write this greater correctly because I don't think it's something else, such that the absolute value of x, then if I take 1 to the other side, I'll get plus 1, you see, right, which is less than delta. Then I'll have the absolute value of x plus 6, which is our f of x, minus 5, which is our L, which this should be less than A. We agree, right? Then we must prove it now. For us to prove this, we must say, we're going to say now, I take the absolute value of this, take the absolute value of x plus 6 minus 5 and say this will be equal to, we have x, 6 minus 5 is what? 1. So when we take the absolute value, the aim is to arrive here. You see, right? When you arrive there, you can now say that this is less than A. We agree, right? Hence, we may choose delta to be equal to E. Then we come to the second question. Is there any question based on this? We'll come to the second question. The second question says, I'm going to take this, says the limit as x approaches, it approaches x over, okay, what x over, let me take this one, number 2, going to have 4 minus 3x over 5, which is equal to 7, right? So first I'm going to plug we're approaching what is it? Then write what we're approaching. Don't write what we're approaching. We are approaching -5. Yeah, so first we need to write what? Given. Right. Given any epsilon greater than 0, we must find delta greater than 0 such that the absolute value of x, if I take 5 to the other side, becomes plus, right? And then this will be less than delta, right? Then the absolute value of 4 minus 3x over 5 minus 7 will be less than a. Alright, I think someone is sending a message. Oh, you just do trick only. Okay, that is too late. So we can now say what? Now. You can say now. Then we have 4 minus 7. What do we get? 4 minus 7 is minus 3. Minus 3x over 5. Which this is equal to. Remember, the aim for this is to arrive here, x plus 5. So what we can do first is take this x plus 5. Write it here. You see, right? Write the x plus 5 there. Then we do this. We take this minus 3 over 5 divided by 5. Let me take minus 3 over 5 divided by 5. So, or I can do this, not minus 3 over 5. Let me just take, if I factor out here, if I want to come back here, let me do this, it's minus, oh, it's fine. I can do this. For simplicity, let's start by factoring out negative, right? So it can be simple. 3x over 5. Yeah. Then here we'll have 3 plus 3x over 5. We agree, right? And then now let's check this. So now I need to factor out something that will give me x plus 5. We agree, right? So if let's say I do this. If I factor out this, let me check if this goes in. Okay, yeah, it's fine. So if I factor out this, if I factor out for x plus 5, right, I should be able to take this, divide by this, and I take that thing and write it here. But that thing, when I multiply back, it should give me this. You see, right? So let's do this. I'm going to, for simplicity also, let me do this. Let me rearrange these ones because I need x to be the first one here so that we can see that we're doing the correct things. So if x is the first one, it will be fine. Yeah. So if you put it like this, it's always fine. Make sure that x is the first one too on the list, right? So it's gonna be simple like that. So I'll do this. I'll write x plus 5 here. All right. So I'm gonna take this 3 divided by 5, right? 3 divided by 5, I get 3 over 5. So you take this, divide by this, you write it here. When you multiply here, you should get this. You see, right? So if you rearrange them like this, you take, again, if you rearrange them like this, you're going to take this. Make sure that you have factored out that negative, right? Because it might give us a problem. You're going to take this, divide by this, then you write it here, such that when you multiply back, it's going to give you back this. So if it doesn't, that's when we're going to say let delta be equals to 1. You see, right? I'm glad we are recording this session so that when you lose some parts, you can just go back to listen to the recording. So this will be 2 value of 3 over 5 x plus 5, which we know that this is less than a. And this will imply that the absolute value of x plus 5 is less than, if I multiply both sides by 3 over 5, or by 5 over 3 because I want to cancel this, must multiply by 5 over 3 to cancel this, right? Even this side will have 5 over 3, you see, right? So I'm going to do that. So I'm going to have 5 over 3e. So we say hence we may choose delta to be equal to 5 over 3e, right? So this is the simplicity on this part. Now we have this question. This one you must write it yourself. I'm going to give it to you as a, I'll say try the limit as x approaches 4 of x over 3 plus 1, which is equal to 7 over 3. You should try this. And then now we come to this question. It says if we're given the limit as x approaches, x is approaching 1 of 2x squared plus 1, this is equal to 3. So same thing, for us to solve this, we're going to write given any epsilon greater than 0, we must find delta greater than 0 such that the absolute value of x minus 1, I take this one to the other side, becomes negative. This will be less than delta. Alright, then the absolute value of 2x squared plus 1 minus 3 is less than a. You see, right? Then I'll say now if I have 2x squared plus 1 minus 3, then this will be equal to 2x squared minus 2, which this is equals, and we're looking for it, we're looking for x minus 1. So we can first factor out 2, and we can factor out, can factorize this, x minus 1, what do we want, and then x plus 1. You see, so what we are not looking for, this we're not looking for this, but we're looking for x minus 1. So when you have this case, having a constant is allowed, but having another variable which is not wanted is not allowed. So for us to get rid of that such a condition, we must suppose, delta is equals to 1, which this would then imply that the absolute value of, we take it from here. You see that it's x minus 1. Or just keep in mind that you take the one that you want and say x minus 1 is less than what? It's less than 1. But always take this one because in some cases they're different. So always take this. If you take this, it will always work. So, and this would imply to minus 1 less than x minus 1 less than 1. Which this would imply, so now let's check. The idea is to find x plus 1. You see, right? From this. So now what we should do, for us to get x plus 1 here, we must add 2. So what is done on the left hand side is done on the right hand side. So I'm going to add 2 here also. You see, right? This will imply that this one less than x plus 1 less than 3. Then since I got what I'm looking for, which is x plus 1, what I need to do now, I need to make sure that this side and this side are equal for me to apply the property. Remember, here I must come and say absolute value of 2 absolute value of x minus 1 absolute value of x plus 1. You see, right? So I must get this. So what I'm going to do, I'm going to take the bigger one. Between 3 and minus 1, which one is bigger? It's minus, here is 3. So I'm going to add minus 3 here from the beginning. And when you put them, they should make sense. Let's say I had chosen 1. Would I put minus 1 here? Is minus 1 greater than 3? No, you see, that wouldn't make sense. So it should make sense mathematically. Whatever you do, let it make sense. So here I did put minus 3. Obviously 1 is greater than minus 3 and 3 is greater than all these, so they make sense. So here I can exclude 1. The reason being is because 1 is within the interval, you see, so I don't have to write it. It's there, but I excluded it. I just decided to exclude it. So since these are the same but they differ in signs, then now I can put this as the absolute value. You see, right? Hence I now know that the absolute value of x plus 1 is less than 3. Then I can come back from that equation. The equation I can say now the absolute value of 2 absolute value of x minus 1 absolute value of x plus 1. This will be less because of this sign, right? I want to plug 3 and they're not equal. I want to plug 3 on this, so I'll keep the sign less. Instead, I want to plug it on this one. So this will give me absolute value of 2 absolute value of x minus 1, and then this is 3. You see, right? And this will be equals to 2 times 3 is 6 absolute value of x minus 1, which this is less than a. You see, right? And then this would imply that the absolute value of x minus 1 is less than e over 6. Hence, we may choose delta to be equal to mean. Don't forget, we first had that delta. We suppose that delta is equal to 1, right? Then I'll write 1 e over 6. So every time you have more than one delta, you're going to write mean. We're saying that could be the minimum number of deltas, but or we may choose, or some would write it as we may choose delta to be the smallest possible number. Is right? That's I'm writing mean. So the solution to that question is like that. Yeah, if you have a question, make sure to open your mic and speak, or you type in the group if you don't want to speak. And then let's do this last one, then I'll give you an exercise, or let me give you an exercise based on this. Let me say try the limit as x approaches 1 minus 1 of x squared minus 2x minus 1, which this will be equals to 2. It's a bit similar to this, you see. So I'm going to give you an example and tell you to try something. So we do this last one. This was number what? 4, it's fine. So we'll make this number 5. Then on number 5, we have this. On number 5, we have that the limit as x approaches 2 of the absolute value of 1 minus 3x is equals to 5. Right? Yeah, it's approaching. Is it approaching 2? Yeah, it's approaching 2. It's equals to 5. And then we're going to write our definition. I'm going to write this. I'm sharing the notes by mistake. Then we're going to write given any epsilon greater than 0, we must find. Right? So we're going to find delta greater than 0 such that now we're going to have this, right? X minus 2, which is less than delta. Then we know that now we must have the absolute value of this. What is that? That is the absolute value of 1 minus 3x. You see, right? Minus 5, which is less than a. Check this. I put our f of x, which is the absolute value. Then I subtract 5. You see, from there, same thing, same approach. I'm gonna say now you must try to look at the approach. Then I say that the absolute value of 1 minus 3x minus 5. You see, right? So this one you should always write like this. You should write this is greater or equals to the absolute value of 1 minus 3x minus the absolute value of 5. You see, right? Then which this would imply that the absolute value of 1 minus 3x, which is minus 5, then I take this one. You see, right? Some would prefer to rearrange it and start with this and say it's less than this, and say that this is less than what? E. You see, right? Which this would imply that the absolute value of 1 minus 3x is less than E plus 5, right? I took 5 to the other side. Then this one I can simplify it to minus E plus 5 less than 1 minus 3x less than E plus 5. Then I have this. Then this would imply that we have minus E minus 5, which is less than 1 minus 3x less than E plus 5. So the aim is to get here to x minus 2. We say, right? So we can manipulate this to x minus 2. First, we can get rid of this one. Right? We can get rid of this one. We must subtract 1 both sides. We can have minus E minus 6 less than minus 3x less than E plus 4. Then I get rid of the minus 3. I'll just divide by minus 3 both sides. I'll have minus E plus 6 all over minus 3, which is greater than x greater. So the sign will change every time I divide by a negative value, right? Greater than minus greater than E over 4 over minus 3. Right, then I can rearrange this. I can take this and start with it because the signs are facing the other side. So I'll have E plus 4 all over minus 3 less than x. Then here I'll have less than, I'll have E plus 6 all over 3. Then now what do we need? Now we need minus 2 from this. Now we already have x. We need minus 2. So we're going to subtract 2 both sides. So if I subtract 3, I'll have E plus 4 all over minus 3 minus 2, which is less than x minus 2, which is less than E plus 6 over 3 minus 2. And this will be e plus 4 plus 6 all over minus 3, which is less than, so if I take minus 2 times minus 3 is plus 6, so I add it on the numerator, I get 4 plus 6 is 10, right? And this will be x minus 2 less than, then this one, and 3 times 2 is minus 6, 6 minus 6 is 0, so I'll be left with e over 3, right? I'll be left with e over 3. You can try this computation on your own. So this will be e plus 10, is it, yeah, e plus 10 over minus 3 less than x minus 2 less than e over 3. So here's what we're going to do, right? We're going to do this. We're going to check this. What are we approaching here? We're approaching 2. So we're going to take this value that we're approaching. So I'm going to write here, but I'll erase, please. This, you just keep it in your mind. Going to let e be equals to 2 because we're approaching 2. You see, right? Then we plug e here, which is 2. If I plug 2 here, I'll get 12 over minus 3, which is less than x minus 2 less than 12 over 3. You see, right? Then there it will be 12 over minus 3. Here we'll have minus 4 less than x minus 2 less than, this one will have 4. Is it 4? Oh, I plugged the wrong value here. Let me do this. I plugged a wrong value here. I'm supposed to plug 4 on e. This is supposed to be 4 here because e is 4. So 4 is 4 over 3. The question is what is 4 over 3? It's 1,33 something. So now you need to choose, right, between these two, which one you're gonna put on the other side. It's either we put e plus 10 over 3 here, or it's either we put minus e over 3 here. You see, right? So because for us to apply the absolute value definition, these two should be the same. This side should be the same as this side. So we're trying to arrive to that. So what we're going to do is try two computations. If I put 4 here, will this make sense? Ask yourself that question. Is 4 greater than 1,33? Yes, this would make sense. You see, right? Then secondly, if I put minus 1,33 here, would this make sense? Is minus 1,33 less than minus 4? No. You see, it doesn't make sense. So choosing this would be wrong because I've tried it here mathematically. It doesn't make sense. So the correct computation would be to put 4 here. You see, right? Don't forget, I'm just writing this for understanding. You're not supposed to write this there. You can write it on the side page when you're trying to check which one to choose. So this would mean that I'm going to choose the other one, which is this one, right? And put it on the other side. Then I take e plus 10 over 3. You see, that is the one that qualifies. You see, right? And then this will imply that the absolute value of x minus 2 is less than e plus 10 over 3, and then I take the positive one, right? Since they're the same, they just differ in sign, so the signs are included within these absolute values. So now you can say we may choose, hence we may choose delta to be equals to e plus 10 over 3, since we didn't assume any delta to be less than 1. You agree, right? Or to be equals to 1, not less. We didn't assume any delta, so we only have one delta. We're gonna use it like this. But if I had assumed delta, I was gonna say this is equals to mean 1, then this one. Any question? Any question? Yes.
You see where you wrote in red using the red marker.
Yeah.
You said you let your E be equals to 2, ne?
Yes.
Can you?
I can't hear you.
You substitute on your left hand side. You substituted E with 2, but on the right you substituted 4.
Oh, yeah, it's not Ibon. Oh, I substituted 4 here. Oh, I didn't see. But it still will be the same thing. If I substitute 2 here, let's put 2. What is 2 over 3? It's 0, comma. Thank you for that. So 2 over 3 is 0, comma 666. So this one would make sense. Still, we would still have this conclusion. It was only that. Yeah, you agree, right now? Yeah, I can't hear you. I don't know if you're still speaking or not. Then try this. Yeah, which is also 6. You should try this. Then also try the limit as x approaches. No, it's fine. You can try that. This was number what? 5. So let's do one last question. The number 6, we have the limit as x approaches 5 of the root of x minus 1, which is equals to 2. Then we're going to write in red, given any epsilon greater than 0, we must find delta greater than 0. I say right, such that x minus 5, the absolute value of x minus 5 is greater than 0 and is less than delta. From this, right, if we take 5 to the other side, we write then the absolute value of root of x minus 1, which this is our f of x, minus L, which is this one, minus 2, is less than a. So for us to solve this, we realize something here, that this require rationalization. So we can say now we rationalize this. Times the root of x minus 1 plus 2 all over the root of x minus 1 plus 2. Right. Then root by root, we're going to get x minus 1. Negative times positive, we get negative. 2 times 2 is 4. We have all over the root of x minus 1 plus 2. Alright. From here, we'll have this is equal to x minus 5 all over the root of x minus 1 plus 2. check this. What we're looking for is x minus 5. You see, right? But we don't have it here. We have it here, but there's a foreign something there that is there, a variable. So that if that variable, so this we can write like this. We can write it as x minus 5 dot 1 over root of x minus 1 plus 2. So we are not looking for this, right? We must get rid of it. And I say that to get rid of that, so let's start by putting this inside the absolute value. This will imply that the absolute value of root of x minus 1 minus 2 would be equals to the absolute value of x minus 5 all over root of x minus 1 plus 2, which this would be equals to the absolute value of x minus 5 absolute value of 1 over root of x minus 1 plus 2. You see, right? So I just separated the numerator and denominator, right? Given that we know that the absolute value of a over b is equal to the absolute value of a over absolute value of b, and our b in this case is this, and our a in this case would be 1, since I was to take this out and put it outside like this, right? And the absolute of 1 is 1. We agree, right? So since we have this, we must get rid of it. For us to get rid of it, we must suppose we should suppose that delta is equal to 1. You see, right? Since delta is equal to 1, this would imply we take it from this absolute value x, the absolute value of x minus 5 is less than 1, which this would imply that minus 1 less than x minus 5 less than 1. And what do we need inside the root is x minus 1, so we need to add 4 here. So we're going to get 3x minus 1 less than 5. Then we need the root, right? We need to put the root both sides. And then we need what? Plus 2. We need to put the plus 2 both sides. Here's x minus 1 plus 2 less than root of 5 plus 2. Yeah, so but we're not looking for this, we're looking for 1 over that, you see. So we must change it. When we change it, we flip this 1 over, the sign will change and face the other side, you see, right? Faces the other side. Automatically this was bigger that time, now it becomes small, so we can rearrange this and write like this. Should be less than 1 over the root of x minus 1 plus 2, which is less than 1 over the root of 3 plus 2. So between this and this, the bigger one is this one, you see, right? So we must add it to the other side. You can confirm with a calculator. So we must add it to the other side, which is less than 1 over the root of 5 plus 2 less than 1 over the root of x minus 1 plus 2, which is less than 1 over the root of 3 plus 2. And check this. This is in between, so we can exclude it. We can say this will imply that minus 1 over the root of 3 plus 2 is less than 1 over the root of x minus 1 plus 2 is less than 1 over the root of 3 plus 2. You see, right? And since these are the same and the only difference is the sign, we can now say this will imply that the absolute value of 1 over absolute value of x minus 1 plus 2 is less than 1 over the root of 3 plus 2. And check this. Let's take it from this question. You see, right? The question that we have there is this. This would imply that the absolute value of x minus 5, I'm just copying that question there, times 1 over the root of the absolute value of x minus 1 plus 2 will be less, because this is less, right? Will be less than the absolute value of x minus 5 times 1 over root of 3 plus 2, and which this is less than a. You see, right? Then this would imply that the absolute value of x minus 5 is less than, I multiply both sides by this. You see, then we'll have the root of 3 plus 2 times a. Hence, we may choose delta to be equal to, since we have two deltas, the first one is this one of, suppose delta is equal to 1. So we're going to use mean 1 and root of 3 plus 2 a. You see, right? Then that will be it. So let me say try the limit as x approaches minus 3 of the root of 1 minus 5x which is equal to 4, and try the limit as x approaches 1 of 2x to the third plus 5x squared minus 2x minus 5 all over x squared minus 1, which this will be equals to 7. Try this. Yeah, so guys, yeah, I think we can stop here on formal definition. We can stop here. Any question?